2.4a, investigation, relations of functions. So this time we're going to take a look at both reflections over the x-axis and the y-axis. Okay, so we're going to take our base graph, in this case x squared, and then we're going to reflect it by doing negative x squared, and then we're going to reflect it another way by doing negative x all squared. Okay, so the difference between these two reflections are, the first one is a reflection in the x-axis. Okay, and then the second one is in the y-axis. Okay, let's take a look at what that actually looks like. Okay, so we know our normal parabola, 41014. Now, if we took each of these and we reflected it, so it would be like negative 2 squared, negative of negative 1 squared, negative of 0 squared. Okay, what would happen is all of these y values would be negative. Negative 4, negative 1, 0, negative 1, negative 4. Okay, and now if we took our x's and we did a negative, so this would be like negative of negative 2 all squared, negative of negative 1 all squared, we would actually get the original. And I'll show you what that looks like on the graph. So on the graph, we know our normal f at x is going to look like this. Okay, that's f at x. Now, plotting the second one, what we're going to get is a parabola that was reflected in the x-axis. Okay, from grade 10, we know that that is a parabola that opens down, right? When we look at that a value, if it's negative, it opens down. Okay, so this is our g at x. Now, what this actually means is that, see this x-axis here? Our parabola flips, okay? And that's important because now when I do our reflected in the y-axis, okay, so this is the y-axis, what ends up happening is this point actually reflects on to this point and vice versa. This point actually reflects onto this point and vice versa. The vertex is just a vertex. It's not going to reflect onto anything because it's already on the reflection line. I'm going to try to follow this a little bit smoother. Okay, so if you can see h at x is actually the same parabola because essentially our y-axis, which is our vertical line of x equals 0, is our axis of symmetry. Okay, all of these have the same size and the same shape. We're not stretching or compressing any of these. We're just flipping them. Okay, we're just reflecting them. So I'm going to set up our domain and ranges. Okay, I'm going to start with XER and YER for all of them. This is at minimum what you should start with. Now, let's actually talk about what the domain and ranges are. So the domain of the blue function is just XER. Okay, we know that our parabola extends to the left forever and to the right forever. Now, we know from parabolas that we need to consider where the vertex is. So for the blue parabola, our vertex is at 0, 0, and it opens up. Okay, those two pieces of information are going to give us the optimal value, which is y. And since it opens up, y is greater than or equal to 0. Okay, for the green parabola, our vertex is 0, 0 again. So XER for the domain, it's going to extend to the left and the right forever. For the range, our optimal value is 0, but this time it opens down. How that's going to change our range is that y is going to be less than or equal to 0, okay, because it opens down. And the third one is just is the exact same as the first one, so we can just put y is greater than or equal to 0. Okay, same reasoning behind that one. So when the negative sign is out front of the function, this is a reflection in the x-axis. Okay, and when the negative is right inside of the bracket with the x, this is a reflection in the y-axis. Okay, number 2, complete the following table of values for our base function root x, and then negative root x, this is supposed to just be root x, and then h at x equals root of negative x. Okay, so we have 3 different functions here. It's supposed to be bluer. Okay, we know our root x function is 0, 0, 1, 1, 4, 2, 9, 3. Now, if we were to plug these values into this equation, we're going to get 0, negative 1, negative 2, negative 3. Okay, pay attention to this. So we can't root a negative number, so the domain that I chose for this one, like root of 0 is just 0, so that's fine, but negative of negative 1, which is just root 1, okay, negative of negative 4, which is just root 4, okay, and so on. I'm going to do this in green. I'm going to do this in red. Okay, so our original function, 0, 0, 1, 1, 4, 2, 9, 3. Okay, this is f at x. Now, if we reflected this in the x-axis, take a look at this. Now, what do the green and the blue graphs look like when we put them together? I'll just call this g at x. Okay, this is the complete parabola on its side. So if you actually notice, and this is going to come back into play, if you actually notice, the blue is not a complete parabola. You would need both parts of it, right? Like the blue and then the reflection in the x-axis, which would give us that green. Okay, now we have 9, 3. Now red. I'm going to go h at x. Okay, and that's clearly, if we reflected the root function in the y-axis, it would go over there. If we reflected it in the x-axis, it would go down here. Okay, so yes, these are all the same size and shape because they haven't been stretched. Okay, now it says state the domain and range for the functions. So setting up the domain and range, both the x and the y are going to have restrictions. Okay, so I'm going to set up the domain and range for each of these. X is an element of the real number system, and y is an element of the real number system. Okay, now what we're looking at here is our fake vertex. So for all of them, they're actually 0, 0. Okay, and now we have to consider where these root functions are moving. Okay, the blue one is going positive x, I'm going to put this in blue, positive x and positive y. Okay, so for the original, x is greater than or equal to 0, y is greater than or equal to 0, and that's it. Okay, now when we consider the green function, so g at x, what's going on here is that now the x values are still going to the right, but now the y values are going down. Okay, so how would we write that? Okay, so 0, 0 is our fake vertex. Now, so x is greater than or equal to 0 since these numbers are still increasing along the x-axis. However, the y's are getting smaller. They're getting further and further away from the origin in the negative direction. So y is less than or equal to 0. They're getting smaller, -4, -5, -6, and so on. Okay, and then the last one, the red one. So red is going to the left this time. Okay, so the x values are going to the negative, so negative infinity. And the y values are going up still. Okay, so if we start at our vertex of 0, 0, the x values are getting smaller, so x is less than or equal to 0. The y values are getting greater. Y is greater than or equal to 0. So what would we say? If the negative sign is in front of the function, this is a reflection in the x-axis. And if the negative sign is inside the function with the x, this is a reflection in the y-axis. Okay, number 3, complete the following table of values for the function f at x equals 1 over x. So we're dealing with our rational function, and then the reflection, -1 over x, and then the reflection 1 over negative x. Okay, so if we were to plot or plug these points in here, we would get -1, 1. There's a horizontal asymptote naturally at x equals 0, y equals 0. And the vertical asymptote is at x equals 0. Okay, if we were to plug this in here, we would get like -1 over -1. So we'd get 1, -1. Here's the thing. This affects the y coordinate, y equals 0. Since this is 0, if we were to reflect any of these, they would just turn out the same. The reason is because 0 doesn't have a sign on it, so it doesn't flip. It just stays on 0. Okay? In other words, 0 times -1 is still 0. Okay? And if we were to take these same it's going to be in green. It's my legend. Okay, if we were to take the same numbers, 1 over negative of negative x, that would still be 1. And then that would be -1. And then reflections don't affect the horizontal or vertical asymptotes. Okay? So let's graph the first one in blue. Okay? I'm going to go y equals 0 is our horizontal asymptote. X equals 0 is our vertical asymptote. And those are our 2 points. So we know that the 2 curves in our 1 over x function are going to lie in these quadrants. Okay, now here's the thing. We already have our asymptotes drawn on our graph. So if we plot -1 and 1, this is what happens. -1, 1 is plotted here. 1, -1 is plotted here. So we should know that we're going to draw our 2 curves in these opposite quadrants here. Okay, and this makes sense. If we're talking about a reflection of the x-axis, what happens is this blue one was reflected down, this blue one was reflected up. Okay, now same horizontal and vertical asymptotes. We're going to plot -1, 1, and we're going to plot 1, -1, and draw. What do we notice? We notice that a reflection in the x-axis is going to actually be the same as a reflection in the y-axis, because this time this was reflected this way, this curve, and this curve was reflected this way. It's actually going to yield the same. So these two are equal. Okay, so yes, this is congruent. And for the domain and ranges, I'm going to set up all of our domain and ranges the same way. Okay, so domain range XCR such that x does not equals. Okay, this is how we set up the domain and range every single time for a rational function. XER such that x does not equals, YER such that y does not equal. Okay, so x is never going to equal the vertical asymptote, which is 0 in all of them. Y is never going to equal the horizontal asymptote, which is 0 in all of them. So all of these have the same restriction. It's going to touch every single number except for when x is 0, so this vertical asymptote, and y is going to touch every single number going up and down except for this number right here when y equals 0. Okay, so simply, this is a reflection in the x-axis. This is a reflection in the y-axis. So in conclusion, when we talk about reflections, there are two types of reflections. Vertical reflection, I don't commonly call it that. I call it a reflection in the x-axis. This is when the negative sign is out front of the function. Okay, so in other words, negative x squared, negative root x, negative 1 over x. That's how that's going to look. Okay, if this a value, whatever number this is, it could just simply be -1, aka a negative sign. If it's positive, then nothing changes. It's just going to be like the original base function. However, if it's negative, then there is a reflection in the x-axis. Okay, a horizontal reflection, I again rarely call it that, or a reflection in the y-axis is when the negative sign is like directly on the x. So negative x squared, root of negative x, or 1 over negative x. You can bracket it if you want. So if this number here is positive, then we just have the original base function. However, if this number is negative, then we have a reflection in the y-axis.